Our guest today is a space architect, technologist, and researcher. She's the VP of Building Design and Performance at Icon, which is a construction technologies company focused on large-scale additive manufacturing, working on structures that shift the paradigm of home building on Earth and beyond. In previous roles, she was a senior research associate with the Human Systems Integration Division at NASA, a co-founder of Space Exploration Architecture, developing human supporting designs for space exploration, and a professor within the architecture department of Pratt Institute. She has a Master of Architecture from Columbia University and a Master of Human-Computer Interaction for Robotics from the School of Computer Science at Carnegie Mellon. Her TED Talk, How to Build for Human Life on Mars, has been viewed over 1.4 million times. She geeks out on new material and fabrication technologies. Me too. And she likes tiny robots. Welcome, Melodie Yashar. It is so wonderful to have you.
Thanks, Emma. Thank you for the introduction. It's great to be with you.
Yeah. Well, those are some amazing credentials. You know, I was going to dive straight into the really serious questions, but I have to ask you, I was so captured by the tiny robots. So can we start with the tiny robots?
Yeah. That's such a great question. So the bulk of my work in the last, 10 years has been focused on construction technologies, right? But in the work that I've done in space exploration, and particularly pertaining to building in space and thinking about in-space manufacturing, everything is much more feasible at a small scale. You're not going to have people on the ground, or you're not going to have people supervising. You're not going to have people who are there in the same way that you do on Earth, building things with their eyes and their hands. So tiny robots are absolutely, and swarm robots, and thinking about how we can be more strategic and smarter about assembly with smaller items is definitely of interest here.
I'm really curious because space architect, that title conjures something really spectacular. So talk to us about what that is and how did you come to even be a space architect?
Yeah, of course. So space architecture essentially is about designing and conceiving habitats that can support human beings in outer space, both in orbital environments, but also on the surface of other planets, such as the moon and eventually Mars, we hope. And so my career trajectory into space architecture happened quite organically. It was never something that I thought would actually come to be something that I would refer to myself as, or a title I would refer to myself as. But essentially, I participated in a number of self-initiated space architecture projects earlier in my career that were met with a lot of success. So I was a team member and a leader in multiple proposals to NASA's 3D Printed Habitat Challenge, which sort of launched myself and my colleagues into a career in space architecture. And we started to get phone calls and recognition from private aerospace companies who were interested in the potential of looking at how human beings can thrive in these environments in outer space. And essentially, it started a consultancy practice, as well as some more applied research where we were looking into what is actually possible in the next 10 years. How can we support human beings in low Earth orbit and eventually on the surface of the moon?
So you're working on environments not just on planets, but also in space.
That's right. Yes, both orbital and on the surface of the planets.
Oh, I didn't realize that. I thought it was all built like Earth-built environments, but that's fascinating that you're actually working on. Because there's an example of a space hotel that is being worked on, and that the idea that eventually we'll be able to vacation in space. There's one environment I can think of in particular that was in Architectural Digest, where they're building, it's like supersized basketball courts with zero gravity and, some really fun things.
Yeah, that's right. There's an a huge industry right now, looking at how we can commercialize low Earth orbit and introduce space hotels and other commercial space stations that would enable us to do a whole array of things and activities, both research, science oriented, but also in this new field of space tourism. So it's a really exciting time to be thinking about this imminent future for space exploration.
Yeah. And I mean, the constraints are so different, right? When you're on Earth, you're dealing with gravity, you're dealing with weather, environment, all of that. In space, there is nothing, right? There is literally nothing except zero gravity that you are architecting, or that's your main constraint, right? We were talking too about, at some point in time, there are now thousands of satellites in space. And, at some point in time, you can imagine that, how do we stop lower orbital environments from accumulating space junk and becoming these worlds that, do you find, is that being thought about?
I wish that there was more of a consortium and more sort of consensus as to what to do about space debris and space junk. For the time being, everyone, and for good reason, is focused on the potential of commercializing low Earth orbit and bringing these new technologies to space. But just in the same way that on the surface of the moon, we have to be very mindful of planetary protection and the implications of what it means to actually be mindful of what's actually indigenous on the planet. We have to do the same for the environment of our orbital kind of spheres, both in cislunar space and also around the Earth. And there's a number of nonprofits that are heavily invested in investigating these new areas. But I do wish that there was more of a consortium with the private aerospace companies so that we can drive towards some consensus and hopefully set some standards relative to how we're going to approach these problems as an industry.
Yeah. I mean, you would think that we've learned from the way that we've done it on this terrestrial planet that we exist on. Most people don't know what ICON is or who ICON are. And ICON is your current company where you're a VP of Build and Design Performance. Do I have that correct?
Yeah. Yes.
Yeah. And the thing that I think ICON is really most notable for, and correct me if I'm wrong, they built the first 3D printed house for around $12,000 and within 24 hours. I mean, that is extraordinary in and of itself. But can you help us to understand what the implications are for that?
Yeah, of course. So Icon built the house that you're referring to is the first permitted 3D printed house in the United States. And so that, in my opinion, sort of set the landscape for a new industry of additive manufacturers introducing housing that could actually be sold and put onto the market at affordable rates and also for market rate housing. So what we do is essentially develop the robotics, engineer the materials, develop software, and also develop architecture and design, supporting how we can create large-scale additively manufactured houses to radically change the paradigm of construction within the housing industry here on out. ICON was co-founded in response to what we consider to be a global housing crisis. Mm-hmm. And one of the key benefits of introducing automated technologies within this area is that we're able to introduce economies of scale that would enable us to drive down cost and introduce a higher quality home product for people and communities who really need it most.
Are you seeing that play out? Like, for example, I know that some of the projects that I kind of worked on are with lower income communities in places like Latin America, in environments that are really challenging, very poor, and you've built communities in these places. How do you see that impacting people? I know that I kind of built a community here in Austin, and it's affordable housing, right? That's the intention for it. But how realistic is it for building companies or construction companies to roll out this kind of building technique and technology? It just seems like a no-brainer to me that we would 3D print houses everywhere.
I completely agree with you. The reality is that the construction industry, like the aerospace industry, is notoriously risk adverse. And both regulators, owners, developers are approaching new technologies with a lot of reserve and taking it as it comes, so to speak. But in our opinion, the value add and the benefits from a performance standard of our system, both in terms of the energy efficiency that we're able to introduce, the cost implications and cost value add that we're able to introduce, far, far outweigh the sort of lack of resilience that is implicit within stick frame construction, and also, of course, the labor shortages which are faced in many parts of the country and other parts globally. So there's a little bit of a learning curve associated with adopting new technologies and innovative ways of building within massive industries like construction. And part of what we do is try to advocate for the benefits of this new way of building so that it can be introduced to more markets and to more customers in the future.
Yeah, I mean, I find it really, really interesting, the whole industry, because I think of companies like Heliogen, right, backed by Bill Gates was an investor in it, harnessing the power of sunlight and using AI to, focus the energy from that to create a new type of concrete. I think about, concrete, for example, and that's the most prolific material on the planet, as I understand it, is concrete, is cement. Having cement or concrete that is able to self-repair. It just seems to me that we have all of these incredible new materials, new methodologies, and innovations that could be used in the world of construction, but there are still these big barriers to entry. I wonder if the other piece of it is the capital investment, because when I looked at the 3D printed house in Austin, for example, and I saw the gantry that was required to actually print the structure, there is an investment needed to buy the equipment to do it. I guess it's no different to the construction equipment that you need in some ways, right? It's just a different way of looking at it. It's not a bulldozer, it's a 3D printing gantry.
Yeah, so there are different business models available. In our case, we are a full service design builder. And so we mobilize our robotics out to a site and essentially deliver the full structure of the home in addition to finishing. Wow. And of course, there are others in the industry who operate quite differently. But in our opinion, we try to remain vertically integrated because we take full responsibility for the performance of our homes, our architecture, as well as our materials. And it's something that we take a lot of pride in. We see our homes and our designs as a product to really change and I would say accelerate and elevate the standards when it comes to housing within the country today. Very often we see folks in the industry basically duplicate an existing home and design that has been built with traditional means and methods, whether it be CMU block or stick frame. And we see there being an entirely new potential in using this technology and using 3D printing to create new architectures that are courageous and divergent and that really accelerate and advance the quality and performance of existing buildings.
What does that look like for you when you say enhance our ability to design differently, like design in ways that are really innovative. And I know one of the conversations happening in architecture are around built environments and how they can better serve the occupants.
Yeah, so there's so much potential in thinking about how to design with and design architecture using 3D printing, essentially as a kind of free-form sort of digitally native modeling process, right? So instead of relying on rectilinear surfaces and straight lines as such as we would with traditional drywall or steel or even cementitious masonry or like CMU block, we're able to introduce curves and undulations and eccentric features within our geometry that you can't really get with traditional means and methods of construction, which rely on essentially industrialized manufacturing processes that bias towards flat surfaces and flat pack materials that get shipped from a factory and need to arrive on a flatbed truck. But with us, we have this ability to really sculpt in 3 dimensions using a 3D printer. And because it is, again, a digitally native process, we're able to introduce so many new architectural features and components that have never been seen within the residential sector before.
I know, and some of them are very beautiful. For anyone listening who wants to go and check out what Icon are doing, it's, the forms are really quite beautiful. There's, and it's not just about the form, right? It's about the energy efficiency that creates when you are able to play with surfaces and build structures in different ways. Then it gives you a lot of latitude to then think about the engineering piece of that.
Yeah, absolutely. Part of what we do in developing architecture in-house is we look for opportunities for how to advance and introduce home products terrestrially, which are essentially advancing what has been seen within the housing market to date. And then, of course, leveraging the advantages of the technology to introduce autonomously constructed habitats in the future on the surface of the moon and Mars. So it's the same technology applied to different sectors, but all of it is advancing a reality in which we're able to leverage autonomous construction for the betterment of humans and their future environments.
There was a headline a few years ago, actually, and I wrote about it, that talked about the cities of the future will be self-assembling. Mm-hmm. And it stopped me in my tracks. And I was like, wait, what? How does that work? And I mean, we already have self-assembling materials, right? You can have something flat packed that arrives at your door, you unbox it. I mean, it's the mattress example, but that's a really, really basic example. I mean, people like IKEA even have been working on self-assembling chairs. For example, you unbox it and the whole thing just slowly comes into being, and it's structurally sound. It's not a chair that's then you can't sit on or it's going to break within 2 weeks of using it. And the same thing with cities. I mean, the premise of the whole idea of this is that eventually we will work with material sciences will get so advanced that we will have materials that we won't even need to build anymore. There won't be construction companies as we know them now. We will program materials and then send them to their destination, and the materials will then just self-assemble into whatever structure it is they've been programmed to become. So is that some of the work that you guys are doing?
In our terrestrial work, we have a material that we've engineered referred to as lavacrete.
Lavacrete. I was trying to remember the name of it. Yeah.
It is a mortar-based cement that we've specifically engineered for our terrestrial construction purposes. The The fascinating thing, and the thing that I think is so exciting about this industry and about the potential of automated construction in the future, is that there is a wide divide between intelligent self-assembly and, let's say, embodied intelligence within certain kinds of materials and metamaterials, and what is actually going to be a structurally sound building assembly that can be permitted, verified, validated according to building code in the future. And I think that bridging that gap is exactly what Icon and other companies are setting out to do, right? So in space, the notion of self-repairing materials is very appealing. And we're also really interested in those applications terrestrially as well. So the more intelligence that we can contribute to any kind of self-assembly or self-repair or a self-monitoring system, particularly when we're talking about pressurized habitats that are, containing that essentially are a depressurization event in space is absolutely catastrophic. So any kind of measure that we can take to mitigate that risk, whether it be through intelligent materials, self-repairing materials, or any kind of intelligent monitoring or health, let's say, surveillance system, is very, very appealing to us when it comes to building design and also assembly of the system.
Why are we aiming for Mars, and why are we not just playing around with and prototyping this stuff on the moon? Is it a different environment, or what? Like, the moon was so much easier for us to get to, right?
Yeah, it's a great question. So Mars is referred to as our sister planet because it appears to be the most livable planet when it comes to the atmosphere, the thin atmosphere that exists there, and also the diurnal cycles. But the reality is that it's very far away and very difficult to get to. A mission to Mars is no small undertaking. And of course, there's lots of hazards and risks that we have to be mindful of, such as deep space radiation and the effects to our crews over the course of these long duration missions. There's all kinds of questions that we don't have answers to from a research perspective just yet. And the moon, of course, is much closer to us. We can get to the moon within a matter of days as opposed to 6 to 8 months. And so it does make total sense to use the moon as a platform for research and prototyping in advance to developing those systems for Mars. So that is precisely the premise of NASA's Artemis missions and the Artemis program moving forward, is that we're using the moon as a platform and a test bed for technologies which would subsequently be deployed in Mars missions. And we want to test and verify that they are actually going to perform the way that we're anticipating, and that we can sustain human beings over the long term on the surface of the moon, in advance to taking on the much larger undertaking of a Mars mission.
Oh, interesting. Okay, that makes sense. So in terms of what are some of the challenges that you faced? Like, I'm curious. You're a woman, and this tends to be a very male dominated environment. And yeah, I'm just curious what your point of view is.
I do think that the barriers for entry are slowly diminishing. And as a manager at Icon, and as someone who is leading a department that is guiding the way for the future of what additive manufactured houses and designs look like, I do my best to be sure that we have a diverse and equitable workforce and team that we are that we're leading into the future. And beyond that, I I try to do my best to be sure that I can represent myself in educational forums and also professional organizations that can bring more exposure and show that, people working in technology and people working in aerospace do not all have to be a prototypical sort of white male. And
yeah, I love that about you. Actually, I love that you are. I mean, you just are by virtue of the position that you're in and who you are. This incredible example, particularly for women and young women, because I know that you've spent some time teaching, and I think you currently still do at the College for Art and Design. And so, the fact that you're able to influence this, younger generation and a new generation to think differently about it, I have such hope and excitement for, our upcoming generations, because there are people like you as a role model for what's possible, particularly for women. And we need that.
Oh, thank you. I agree. We do need that. Absolutely. And the other thing that I try to do and try to maintain is a position or participation in multiple professional organizations, both in the construction and the building design sector, but also in aerospace as well. So having that kind of representation across the board, I think, is very important. And I really encourage younger folks to get involved and to participate in these subcommittees, whether it be a professional or technical organization or even smaller groups, non-professional related meetups and groups and that type of thing. And it will really change what the future workforce looks like and what the future of these industries it will actually be.
Yeah, I agree. So how do you see architecture evolving? Like the scaling back out and thinking about architecture and built environments in general, like what do you see as the evolution of the way that we think about our built environments on world and off world?
I think that the future of the built environment will be led by robotic construction. It will be led by intelligent sort of assembly paradigms. It will be based on and informed by smarter and more intelligent machine learning algorithms that can identify problems before they happen, make construction processes more efficient and time effective so that it isn't it doesn't move at the glacial pace, which is so traditional and so sort of accepted. And because of that, I'm hoping that it will also enable us to introduce housing and architectural solutions and also infrastructure scale solutions in areas that are most needed. The funding for massive construction and infrastructure projects is no small undertaking. And I think that with smarter technologies and more efficient technologies, we'll be able to pave a path for addressing those problems in a just-in-time manner, and also introduce solutions for the communities that really do need these buildings and these other paradigms.
And I love that focus. I mean, you guys are not just focusing on the big Mars vision, but you're also really doing a lot of work on the ground here, as we talked about earlier, in those lower income communities and environments where housing is so desperately needed. So there's something about that juxtaposition and the two ends of that spectrum that I love about the work that you guys are doing. I think it's really important, and it shows a lot of heart, that you really care about the environments that you're building. You really care about what you're doing. It's not just about aiming for the moonshot vision of being able to create built environments on Mars, but it's very much about how can we help our communities here on Earth too. So, I really salute you guys for that. So just to finish up then, I want to ask, like, when you think about your ideal vision for the future, your ideal vision for built environments in the future, what is that? What does that look like? And what does that mean? Because it's not, in some ways, it's not just about construction, right? It's about how we even want cities to look like. How do we want them to function? What do our communities look like? How do we want our built environments to foster different functionalities? I think about NEOM, and I think about some of Neri Oxman's work, and I think about some of the really extraordinary, kind of very out there, like on the fringes of our built environments that people are working on. Are they ideal? I don't know. I don't know that there is any one answer, but I'm curious what your perspective on all that is. And yeah, if you could design, the perfect built environment, what would it be?
Yeah.
And perfect being subjective, by the way, because I don't know that there is such a thing.
Yeah, of course.
Yeah.
I think that an ideal future for the built environment is one which is that is leveraging data that we have on what building performance and building science actually should be and would be most optimal for the most sustainable architectural solution that we can introduce in various regions around the world. I think too often we introduce architectural and design solutions which are not optimized and are not efficient for the environment that they're created within. And frankly, I think that it's a knowledge dearth that we're facing, and it's a lack of knowledge when it comes to bringing the information that's most necessary to the building practitioners that are actually responsible for creating our built environment. So what that means is introducing lots of data about how we should be designing for various climates, how we can introduce materials that are more sustainable and that are going to be better for the built environment over the long term, being mindful of what that means for carbon emissions, and bringing more information to the table about the origins of our materials and means and methods of construction so that we can introduce a smarter and more efficiently designed building for the future. And the more that we can bring these values to the table and introduce I guess we could say like a knowledge base or a knowledge platform that's shared and united amongst building design and architectural professionals and engineers as well. I think that we're going to have a better path for the future when it comes to architecture and design.
Yeah, I absolutely agree. And actually, there's something that you said just then too about, being location specific. So Indigenous communities, for example, they use local materials to create their built environments, whether it's a kind of an extreme example might be the igloo, or another example, the architect who won the Pritzker Prize last year. It was surprising because it was for a built environment in Africa using locally sourced materials, sustainable construction, considering everything, impacts on the environment, how it would serve the community. And there's something about like being deeply respectful and reverent for materials that already exist in these environments and that have served the communities for thousands of years, right? And so really working with not just climate, but people's needs and what can be locally sourced.
Leveraging local economies and local materials is absolutely the way of the future when it comes to designing and building in different environments.
And you'll be speaking at South by again. Are you going to be there?
I'm going to be on a number of panels having to do with space architecture. One of them is titled Space Architecture for Spaceship Earth, and another one is a panel about a publication called Space Feminisms, which should be released in the coming months. And it's going to bring together some of the authors, including myself, from that publication. People, Planets, and Power. The publication is called Space Feminism, People, Planets, and Power. So we'll be talking about the work that's been written in that publication and what to look forward to.
Okay, whoa. We did not even touch on space feminism. Like, what? Wait a minute. Okay, so before we let you go, Space feminism? Are you kidding? What? Okay, what is that?
Yeah.
What is doing?
The idea of space feminism, well, there's so many different ways of looking at it and defining what space feminism is. The piece that I wrote for the publication had a lot to do with equal and equitable representation of multiple actors that are going to be doing work and leveraging technologies on the surface of the moon. And so we have to be thinking in the future of what it means and the implications of maintaining a kind of imperialist and colonialist sort of presence on the surface of a planet, which also has lots of implications for indigenous planetary protection, as well as for indigenous communities who want to keep that space and those materials and those resources protected. I actually recently learned just earlier this week that the Navajo Nation made a public outcry about the Peregrine mission that was launched by with the recent astrobotic launch for a lander to the moon, and they made a public appeal to the White House and had a hearing saying that they were in disagreement that the lander should land on the moon based off as part of the current mission. And so there are lots of voices that have strong opinions relative to what it means to colonize the moon, which is a very loaded term in and of itself, leverage materials and resources on the moon, and what it means to maintain a permanent human presence in the future.
Wow. Interesting. Yeah. I can't wait for that to come out. I'll keep an eye out for that. That's fascinating. Yeah, I mean, I hadn't actually, if I'm going to be honest, given that any thought before, but I mean, we're talking about a lot of the parameters and the things that we're trying to shift here terrestrially, right? Apply in space. And we don't, like, if we have an opportunity to build something off-world, then why would we build it in the way that we have, that we know is just not working for everyone?
Yeah. The whole idea of building in space and this idea of blank slate development is, I hope that we would leverage our learnings when it comes to introducing more, let's say, inclusive planning practices, and also infrastructural development practices, so that we can get it right in the future and introduce a kind of, let's say, infrastructural solution for new space that is diverse and equitable as well.